getting into graphing next. Just kind of a heads up, guys. We're going to cover sections 6 and 7, and then we'll be doing our next test. Probably looking at tests on Tuesday next week. I'm really trying to avoid a Monday test, so shooting for Tuesday next week for our test. So in Algebra 2, you guys did a lot of graphing, and you did transformations, but you really only did it with parabolas and absolute values. And we're extending that this year. We're going to talk about a lot of common functions that we're going to see. In the next section, we'll look at the transformations on those. But this section is basically going through all of the common ones that we might see, and I would expect you to be able to graph for me. And we'll look at some of those properties that go with each. One thing we're going to talk a lot about is what does it mean to be continuous? And the very informal definition is if you can draw it without picking up your pencil, it's continuous. So if I just draw this, that's continuous. But if I do this with an open circle in the middle, can I draw that without picking up my pencil? No. So this is continuous, this one is not. We will be listing intervals when we talk about continuous. Just like with increasing and decreasing, when we do those intervals, we will list the x value. The only time you are going to do an interval with a y value is when you're dealing with a range. Otherwise, always stick with the x. So that is the first example on here. I want to know the intervals of continuity for each function. Let's assume these just keep going. There's no endpoints here. So is this one ever not continuous? Actually, I don't know that you can hardly tell, but there is an open circle right here. You might have to kind of draw that in. Shrunk it down when I put it on your paper. It's really hard to see. But that's supposed to be an open circle right there. So where is it not continuous? 2. At the point 0, 2. So it is continuous, and we're going to list the x values. So coming from left to right, we always go small to large. So it's coming from negative infinity, stopping when we get to 0 because we want the x value at that point. It gets a parenthesis because it's not continuous at 0. And then it picks up again at 0 and goes forever. So that's just another way of saying it's continuous everywhere except when the x does equal 0. All right, B. Let's assume again these keep going. So where is this continuous? So if I start drawing this, when do I have to pick up my pencil?
Never.
Never. So we would say negative infinity to positive infinity. It's always continuous. C. What would that one be? Everywhere except 2. So negative infinity to 2. Union 2 to infinity. And D? That one's continuous everywhere. Hardest thing to remember is the same issue that we sometimes have with increasing and decreasing. You're only using that x value, not the y. Okay, so now we have our common functions. The first function is the identity function. F of x equals x. F of x is the same as what? Y. Y equals x. That's something we should be able to graph after the last couple sections. Y equals x, that's just a line. Y-intercept of 0. Y equals mx plus b. The y-intercept is 0. Slope is 1. So f1 over 1. You only need 2 points. I just can't draw straight lines, so sometimes I put more. Pretend that's straight. So that's my identity. I should be able to ask you questions off any of these. What I expect is if I say identity, you should know what I'm talking about. The f of x equals x. You should be able to draw me that graph. As far as other questions I might ask, domain, range, increasing, decreasing, I'm not expecting you to just memorize all of those. But if you're looking at the graph, you should be able to tell me, what's the domain of this? What's the range? If I asked you, is this increasing, decreasing, or constant? Increasing from negative infinity to infinity. Is it continuous?
Yes.
Yes, negative infinity to infinity. So I should be able to ask you any of those questions. And you should be able to look at the graph and answer them. Okay with everybody? Next one. F of x equals x squared. What's that look like? Parabola. Okay, I would expect, and my general rule, any of these graphs, I'm going to want a minimum of 3 exact points. So we can get those just by plugging in some numbers. 0 squared is 1 squared, 2 squared, 3 squared is 9, negative 1 squared is 1, negative 2 squared is 4, negative 3 squared is 9. Definitely more than 3 points, but we have graph paper right in front of us, so it's not hard to plot those. So to get those exact points, I'm really just making a t-chart. I just didn't take the time to write it out. I just kind of talked through it. Does everybody know where those came from? What's the domain of this one? Mm-hmm. What about the range? Mm-hmm. So how do we write that in implementation? Mm-hmm. And since it hits 0, it gets a bracket. What if I asked you increasing, decreasing, constant? What's this graph do first? It increases, and again we list the x from negative infinity to 0. And then what's it do after that? Increases from 0 to infinity. Where is this graph continuous? Everywhere. Negative infinity to positive infinity. Next, our cube function. So x cubed, if we wanted to get some points, we just plug in numbers. 0 cubed is 0. 1 to the third is 1. 2 to the third is 8. Negative 1 to the third is negative 1. Negative 2 to the third is negative 8. You remember seeing this one before? That looks like a chair. Domain. Range. Increasing, decreasing, constant. This one's increasing from negative infinity to positive infinity. Any issues so far? Square root. What kind of numbers do I have to plug into this? Positive numbers. Can I do the square root of 0? Yeah, square root of 0 is 0. Square root of 1 is 1. What's another nice number? 4. Square root of 4 is 2. One more nice number? Square root of 9 is 3. This one we can't plug in negative, so it doesn't extend in the negative direction. Just goes this one way. Okay. Domain. Range. Is this one increasing, decreasing, or constant? Increasing from 0 to infinity. Okay. Cube root. Can you do the cube root of negative numbers? Yes. You can't do even roots with negatives, but you can do the odd roots. Okay, so we just have to kind of figure out what we can plug in here. So the cube root of 0. Cube root of 1. What's another positive number we can plug in? 8. Cube root of 8 is 2. All right, what's the cube root of negative 1? Negative 1. Cube root of negative 8. Domain. Range. Is this increasing, decreasing, or constant? Increasing the whole time. Okay. Why don't you guys, the last common one that we're looking at here is the absolute value. You've done that one a lot. Why don't you see if you can draw the graph and tell me domain, range, increasing, decreasing. So what's the graph of an absolute value? Absolute value 0, 0, 1, 1, 2, 2, 3, 3, negative 1, 1, negative 2, 2, negative 3, 3. So we've got this V. Domain hits everything. Make sure when you do your infinities you're using those parentheses. Parentheses mean not equal to. Range, small to large, it hits the 0, so 0 gets a square bracket to infinity, and infinity gets a parenthesis. What's this first section doing? Decreasing from negative infinity to 0. Technically, with increasing and decreasing, on that 0, it is not going to matter if you do a parenthesis or a bracket. Either one is correct. And then after that, it increases from 0 to infinity. All right, all of these functions that we've graphed have been continuous on their entire domain. We haven't done any that you couldn't graph it without picking up your pencil. We start running into functions that are not continuous when we get into piecewise functions. So let's see if we can do one or two of those, and that'll probably be about where we end up today. I'll probably do a couple. So a piecewise function, it doesn't have a clear cut. It's always going to look like this. Basically, piecewise just means you have different rules on different parts of your graph, different rules on different pieces of the domain. And so when you graph these, what you did is made a t-chart for each piece. So for instance, if I want to look at this piece, so we make our t-chart, and I like to write it out for these piecewise functions just because we can get into functions that have 3 or 4 pieces. They don't have to be linear. We might have one piece that's a line, one piece that's a parabola, so we need a little more. It says that x has to be less than 1. So we can put in any number we want that's less than 1. We still do have to put in the 1 because that's our starting point. But because this couldn't be equal to 1, when we graph that, it will be an open circle. And then we need to plug in things smaller than 1. So maybe a 0 and a -1. I usually go with a minimum of 3 points. You can do more if you want. We're plugging these in right here, 2x plus 4. So if I put in a 1, 2 plus 4 is 6. If I put in a 0, 0 plus 4 is 4. If I put in -1, -2 plus 4 is 2. When I go to graph this, I have 1, 6. That's an open circle. That's the only open circle on my graph. It's just that endpoint. The rest of them are closed circles. So then 0, 4, -1, 2. Now the next issue comes when I need to draw this line. People want to just keep it going both ways. But remember, we started with this point, and then I could only plug in things smaller than x. So it continues that direction only. So I get that for my first piece. So now we do the second. Still have to plug in 1. Will this also be open? This time it had an equal to, so it'll be closed. And then I need things greater than 1, so maybe a 2 and a 3. So if I plug in 1, 4 minus 1 is 3. 4 minus 2 is 2. 4 minus 3 is 1. So 1, 3. 2, 2. 3, 1. This was my starting point, and then we are going with things greater than that, so this extends to the right. At the end, this was a function. It started out f of x equals. It's a function, so it has to pass the vertical line test. So do a quick check on your graph. Make sure you don't have lines going over the top of each other or 2 closed circles lined up. That's a big indicator that you did something wrong. Let's do domain and range for this one. It's more interesting. Domain, as I go from left to right, so this is hitting all my negatives. It stops here at 1, but the next one picks up at 1 and keeps going. So what's my domain? The range. So range, I've told you we go from the bottom up. So these are going down forever, so it's coming from negative infinity. So when I'm coming up, the green one stops here at 3, but the red continues. So it doesn't stop until we get to 6. But because that's an open circle at 6, it gets a parenthesis. increasing, decreasing, constant? What's the first section of my graph doing? Increasing. It's coming from negative infinity and it stops at, careful, 1, because we have to use the x value. Because that is an open circle, we do have to use a parenthesis there. What's this section doing? Decreasing. Starting at 1 and going to infinity. I wonder if I said, where is this graph continuous? Everywhere except 1. 1 is what we call a discontinuity. It's a break in the graph. So it's continuous everywhere else. So from negative infinity to 1, union 1 to infinity. Why don't you guys take a second, see if you can graph this one for me. And if you get done, you're waiting, go ahead and do domain range, increasing, decreasing, continuous, that stuff. I'm seeing a lot of different answers on this one. So for the first piece, what do you have to plug in first? 0. Would it be open or closed? Closed, because I have an equal to, and then what other kind of numbers? Since it said x was less than, you have to go with the negatives from there. Alright, so opposite of 0 is 0, minus 2 is negative 2. Opposite of negative 1 is 1, minus 2 is negative 1. Opposite of negative 2 is 2, minus 2 is 0. So 0, negative 2 was closed. Negative 1, negative 1. Negative 2, 0. This was my starting point, and then we're extending it for things less than that. So it keeps going this direction. Second one. What do you have to plug in first? But it doesn't have an equal to, so that means it would be open. And then we want things greater than that. If you notice, we're going to be multiplying by a half. So you could plug in 1 and 2 if you want to avoid fractions. You could do like 2 and 4. There's no rule that says what you have to put in. Okay, so 1/2 times 0 is 0. Minus 2 is negative 2. 1/2 times 2 is 1. Minus 2 is negative 1. 1/2 times 4 is 2. Minus 2 is 0. Now when I go to graph this, 0, negative 2, I said open, but when I go there, it's already closed. You can't have an open and a closed at the same point. So if that happens, that we have an open and closed, but they end at the same spot, you just leave it as a closed circle. And we have 2, negative 1, and 4, 0. So right here, and it goes like that. So a point is either open or closed, not both. All right, let's do domain, range, that kind of stuff. So domain, looking at my x values, what does this hit? So negative infinity to positive infinity. Range is looking at my y, so if I'm starting at the bottom, the lowest point is negative 2. And then this is going up forever, so negative 2 to infinity. Increasing, decreasing. What's the first section doing? Decreasing from negative infinity until 0. Good. Technically, it doesn't matter if you put a parenthesis or a bracket on the 0. And then after 0, what happens? Increasing from 0 to infinity. Where is this graph continuous? The whole time. Even though there were pieces, the pieces matched up, so it's always continuous. Okay, questions at all? So, we aren't done with this section. We have gotten through a lot. We still need to practice some more with the piecewise, and then I want to look at the greatest integer function tomorrow. So I have a handout. This will be due on Wednesday. So tomorrow I'll finish the section, and then whatever homework, whatever you don't get done tonight, you can finish up tomorrow. Technically, you could probably do most of this now. If it were me just trying to break it up, maybe shoot for like the front side tonight and the back side tomorrow, but whatever, you've got a little bit of time right now, so see what you can get done.